Select the choice that is a graph of the function negative x plus 4 over x minus 3 times x minus 8. So there's different aspects that are really important for a graph of a rational, and those are the location of any x-intercepts, any y-intercepts, any vertical asymptotes, or any horizontal asymptotes. So x-intercepts are locations where the numerator would be 0. So if you have this in factored form, just take the factors and set them to 0. So if I take x plus 4 and set it to 0, I get negative 4 as an x-intercept. Similarly, vertical asymptotes occur at zeros of the denominator. So setting these factors to 0, I have vertical asymptotes at 3 and 8. So let's see what we can eliminate from just these items. So I have two vertical asymptotes. So right off the bat, I can throw this one out. The first one looks fine because the asymptotes there's two of them in the right location. This one only has one asymptote, so that's not a possibility. This one has two, and it is in the right location. All right, now, next up, we have x-intercept at negative 4. So here's negative 4, and it's kind of hard to see there, but I could buy that the graph is crossing there. So we'll leave that in as a possibility. And here, likewise, the graph gets so close to 0 after a while, it's hard to tell. But it's hard to say that that's not an x-intercept, just based off of the scale. So we'll leave both of those as possibilities for now and see if there's other things that can rule this out. So the other thing that might be able to rule this out, it does appear that the horizontal asymptote for each of these is at 0. So I don't think the horizontal asymptote is going to be all that helpful. And yeah, I guess the degree of the numerator is smaller than the degree of the denominator, so the horizontal asymptote would be at 0. So that doesn't help. But the y-intercept, I think the y-intercept could help here, but it's a little bit difficult to come up with the y-intercept as easily as the other items because we have to do some computation since it's in factored form. But essentially, the y-intercept, what we're doing is we're calculating f of 0. So if I plug in 0, that would be negative 4 in the numerator because of this minus here. Then in the denominator, it's negative 3 times negative 8. So this is negative, well, let's see here, to make this easier. 4 goes into 8 twice. So I have 3 negatives, so the result's going to be negative. So negative 1 over 6. So negative 1/6 is my y-intercept. And if I have a y-intercept that's negative, that means this graph here can't be the item because it has a y-intercept that's positive. So this one here is the only option that matches all of those criteria.